12th standard Tamilnadu State Board Physics order electric field along the axial line of the dipole and electric field along the equatorial plane of the dipole ரெண்டுத்தோட derivations பார்ட்டும் பார்க்கலாம். As you are having the revision exam, just keep on studying the first chapter today. If you complete the chapter 1 today, that will be easy to go at the last. No need to urge at that time. So better concentrate and spend your time correctly. Study both the subjects. It is not that you have to study only physics or maths. You can study both the subjects as you are having a holiday now. Okay, just a revision about the first chapter, which about in first chapter the electric field along the axial line and equatorial line. We know how to calculate the electric field, and electric field we can calculate by E is equivalent to F divided by Q or F equivalent to QE. This is the two important equations or equation which we have to remember always. The electric field value is given by E is equivalent to F by Q, or we can say the F equivalent to Q into E. This is electric field value, and electric field value after finding the value with respect to the distance, how we can with respect to the K, how we can, so E is equivalent to 1 by 4 pi epsilon naught. E is a vector quantity, it's not a scalar, so vector. So put a vector. E is equivalent to 1 by 4 pi epsilon naught Q divided by R square into R cap. So very important equation which you have to remember whenever we study about the electric field. Electric field E vector is equivalent to 1 by 4 pi epsilon naught Q divided by R square. And next one, what is meant by dipole? Two equal and opposite charges separated by a small distance. Two equal and opposite charges separated by a small distance is known as the, and which constitutes the electric dipole. Exact definition if you are talking, then two equal and opposite charges separated by a small distance constitute an electric dipole. And two equal and opposite charges, how we can say, one is if it is minus q and the other one is plus q, both are separated by the distance 2a. Where 2a is the distance between the two, one is minus q, another one is plus q. This is known as the dipole. Always we take 2a is the distance between the two, so minus q and plus q, and the distance between the two is taken as 2a. And what about the center? From the center, if you go for, this is located at the distance a, and this is also located at the distance a. If you keep along the x-axis, plus q is located along the plus x-axis and minus q along the minus x-axis. So you have to take the vectors as plus j cap and minus j cap. So that and all, when we go for the vector analysis, we can concentrate these things. Okay. So E vector is equivalent to 1 by 4 by epsilon naught Q divided by R square, which is electric field formula. And the another one is, what is dipole? Two charges which are equal and opposites and they are separated by the distance 2a is known as the electric dipole. So now the case 1, electric dipole. What is the electric field value when we are taking about due to the electric dipole? Due to an electric dipole at a points on the axial line. So what we are going to see on the axial line, what is the value? So first to take the dipole. This is dipole, and dipole here minus q, and here the value is plus q. Along the axial line I am taking. Along the axial line means where you kept the dipole in the same axis, and here I am taking the point SC, which is located along the x-axis only. So E value, E vector I am going to find at the point C, where it is located along the axial line of the dipole. Here point C is taken. And this one, the distance between the two dipoles, which we know is already 2a. What is the value we take? 2a. And consider that the point C is located at the distance r from the dipole, center of the dipole. So from the center, the dipole, the test point is located at the distance r, and what is the half of the distance is a, and this half of the distance is again a. Now if you go for the distance from the plus q to c, what is the distance? இது ரெண்டுத்துக்கு நடுவுல என்ன distance ங்கறத நம்ம பார்க்கணும் இல்லையா? So if you go for the distance, then This is the total distance which is from the center to the test point R, and half of the distance is A. Then R minus this A is the distance. This is R, this is A. So what is this one? R minus A. What is the distance from the plus Q? That is R minus A. So what is the distance from the minus Q? Minus Q ல பாத்தீங்கன்னா அதனோட distance என்ன இருக்கும்? This distance is R. Add this value which is plus A. So it gives you the distance R plus A. So from plus Q it is located, test point is located at the distance R minus A, and from minus Q the test point C is located at the distance R plus A. So this is fine. Okay, distance value now we got. And the electric field value, if you go for the electric field value, the plus Q, consider this is a test charge which is always positive. Always we consider the test charge as a positive charge only. So if I keep the positive charge, this positive charge and positive charges will repel each other, because like charges will start repelling. So the electric field, or one point is that one, or we can say the positive charge is kept. So the electric field due to the positive point charges is always away from the charge. So you have to take the E plus value away from the point charge, away from the positive charge plus Q. And E minus Q, the direction of the E minus Q will be always towards the charge. So take E minus Q towards the minus Q value. So E minus will be towards the minus Q, and E plus Q will be away from the positive charge. So these are all the two considerations. Means the direction of the electric field, if you go for, one is E plus Q, another one is E minus Q. E plus will be away from the positive charge and E minus will be towards the negative charge. So take the direction. If you go for the magnitude, which one will be greater? As the test point is closer to the plus Q, the E plus will be greater than comparing to the E minus. So E plus always gives you the greater value in this case. So what is the value of E plus and E minus? Just add the values. E plus vector, E plus will be according to the formula. What is the value? 1 by 4 pi epsilon naught plus Q divided by, what is the distance between both? R minus A the whole square. Okay, so E plus will be 1 by 4 pi epsilon naught plus Q divided by R minus A the whole square. And consider the dipole moment, which is P cap. P cap. The next one is E minus Q. E minus Q will be 1 by 4 pi epsilon naught minus Q divided by R plus A the whole square into P cap. So distance, what is the distance? Plus Q is located at the distance R minus A, and minus Q is located at the distance R plus A. So 1 by 4 pi epsilon naught plus Q divided by R minus A the whole square, and 1 by 4 pi epsilon naught minus Q divided by R plus A the whole square into P cap. Now according to the superposition theorem, we have to add. According to superposition theorem, what we have to do? We have to add both the electric field. So add the value. E total will be the sum of E plus Q vector and E minus Q vector. If you add the values, 1 by 4 pi epsilon naught is common, Q is common, 1 by R minus A square, and here 1 by R plus A the whole square. So only that is left. So Q divided by 4 pi epsilon naught into 1 divided by R minus A the whole square minus 1 divided by R plus A the whole square into P cap. What is the value? 1 by R minus A the whole square here minus R plus A the whole square. Now take LCM, minimize the equation more. Q divided by 4 pi epsilon naught into R square plus A square plus 2RA, this expansion, minus of this one, that is minus A square minus R square, minus you will get here, minus into minus will become plus. So plus 2RA divided by A minus B the whole square into A plus B the whole square, which gives you R square minus A square the whole square. A square minus B square the whole square into P cap. Okay, now these terms r square, a square, r square, a square will get cancelled. Only 2ra and 2ra is left. So if you add those values, what you will get? Q divided by 4 pi epsilon naught into 2ra which gives you 4ra divided by r square minus a square the whole square into p cap. Okay. So divide these also. 4ra we are having, as we want in terms of 2, because we know that 2qa is equivalent to the dipole moment p vector value, and here we are having 4. Take q inside. What you will get? 1 by 4 pi epsilon naught 2 into 2qa. Q I have taken inside the bracket. So 2 into 2qa into r divided by r square minus a square the whole square into p cap. Okay. So 2 into 2qa into r divided by r square minus a square the whole square into p cap. Next what we have to do? Consider that the r is very greater than the a value. What is r? R is the distance between the center of the dipole to the point C, and a is the half of the distance. A is the from the center where one of the charge is located is taken as a. So if you neglect, consider the r is greater than a. We can consider the r value is very greater than a. So neglect a which is at the denominator. What you will get? 1 by 4 pi epsilon naught 2qa is p vector. Comparing with the p cap, we will have p vector r divided by r square the whole square. Okay. So p vector, how I took the p vector? 2qa p cap can be rewritten as p vector. Then here power 4, this will get cancelled, which will become 3. So what is the value? 1 by 4 pi epsilon naught 2p vector divided by r cube is the e vector of a dipole when it is kept along the axial line. Along the axial line, when you keep the test point, a test charge, the electric field due to the dipole is given by 1 by 4 pi epsilon naught 2p vector divided by r cube. 2p vector. What is p vector? P vector is the dipole moment. A dipole moment value we can calculate by multiplying 2qa. So don't forget that also. That is also very important. 2qa into p cap gives you the dipole moment value. This is E vector when we are calculating the E vector along the axial line of the dipole. You have to calculate along the axial line. First derivation is along the axial line, and second derivation is along the equatorial line. Equatorial line is nothing but which is located 90 degree perpendicular with respect to the axis where you kept the dipole. So if equatorial line, next derivation is equatorial point. Equatorial line, nothing, very simple. Take a dipole which is minus q and plus q, and the equatorial line perpendicular to the axis of the dipole. If this is the way I keep the dipole, then the equatorial line is taken just perpendicular 90 degree with respect to the dipole axis we have to take. So that gives you the equatorial plane. As I am indicating, that is a plane value. So take a surface which is plane and take a point on that line, on that surface, which is test point C. I am taking the test point C on the equatorial line, then join both the things, means electric field along the plus q and minus q we have to calculate. As already said, this is a plus q, so the electric field will get away from the dipole, and this is a minus q, electric field will get towards the point charge. Okay, so this is E plus q vector and this is E minus q vector. E plus q vector will get away from the positive charge, E minus q will get towards the charge. So E minus q will be towards the minus q and E plus q will get away. So if you go for those two vectors, again the same thing. What is the distance? This distance is a, this distance is a, means total distance is 2a, and from the center that point, test point is located at the distance r. From the center, always the test point is located at the distance r. If we take any triangle, as both are similar, This is A value, this is R, means this is according to Pythagoras theorem, this is R square plus A square, root of R square plus A square. Then draw the vectors. What about the two vectors which is getting away from and towards the charges? This is E plus Q vector and this is E minus Q vector. As they are making an angle, this is angle theta and this is also angle theta. If this is the angle, then if you go for the resultant vector, here also the angle theta, here also the angle theta. We have to consider the angle theta also. So this is a resultant vector. Whenever we calculate, this is triangular law, right? Vectors law. Whenever we consider the two vectors which is getting away from each other, then draw a resultant vector in between. So if you go for this is theta and this is also theta, we have to divide the component. This E plus Q is making an angle with respect to the resultant vector. Okay, so whenever the vector is making an angle, we have to take two components. Remember, vertical component and horizontal component. Towards theta, cos theta, and opposite sin theta. Whenever we draw the free body diagram also, we consider in the same manner only. So when the angle is making, E plus Q vector is making an angle theta. So consider the 2 points, which is vertical component and horizontal component. And horizontal component towards theta is taken as cos theta and opposite it is taken as sin theta. So go for this vector. What is the value here? E plus Q cos theta. And what about this vector? E plus Q sin theta. Similarly, go for this one also, E minus Q, and this is along the resultant vector. So E minus Q cos theta. And what about this component? E minus Q sin theta. E plus Q sin theta and E minus Q sin theta. If you look at the direction, they are just opposite to each other. If you go for vector notification, then here I will have the plus j cap unit vector and here I will have the minus j cap. Both will get cancelled and both the vectors, that is horizontal component E plus Q cos theta and E minus Q cos theta, both are acting along the minus x direction. So here also I will have minus I cap and here also I will have minus I cap. So the resultant vector will be according to the superposition theorem, as these two vectors are acting opposite to each other, they will get cancelled. So no need to bother about this component, which is vertical component. We have to take care only about the horizontal component. This horizontal component E plus Q cos theta minus I cap and E minus Q cos theta minus I cap. When you want to find out the resultant vector, which is the vector sum of these two vectors, the resultant vector, just add these two values, E plus Q cos theta into minus I cap and E minus Q cos theta into minus I cap. So if we add these two vectors, we'll be able to find the total electric field when the point is taken along the equatorial line, on the equatorial line. So what is E total? E total will be sum of E plus Q cos theta into minus I cap plus E minus Q cos theta into minus I cap. So two vectors, E plus Q cos theta into minus I cap and E minus Q cos theta into minus I cap. As we know, they are located at the same distance from the charges. This distance is A, this distance is R. And what about this distance? This will be the, according to Pythagoras, that will be R square plus A square. So both the charges, if we go for the minus Q as well as the plus Q, as the distance, two distance remain same. According to Pythagoras also we can draw, or according to the theorem of the triangular also we can solve, this distance also will remain same. When the distance remains same, the magnitude remains same, which is E plus Q and E minus Q will be equivalent to. Go to the formula. What is the formula? 1 by 4 pi epsilon naught Q divided by, what is the distance? Root of R square plus A square. If you take the square, you will get R square plus A square. Or you can substitute root of R square plus A square, taking the square again, then R square plus A square. In that way also we can represent. No need to bother about that much. Directly you can write R square plus A square is your E value. So what is E vector? E plus or E minus, that is equivalent to 1 by 4 pi epsilon naught Q divided by R square plus A square. So this is easy. Now we have to be very careful along the cos theta components from this triangle. This is theta. So when it is theta, what is the value of cos theta? How to find out the cos theta value? Cos theta value we can, this is what R. Cos theta value we can calculate by taking the adjacent and hypotenuse. Adjacent is A and hypotenuse value is root of R square plus A square. So what is cos theta value from this one? Let us find out the cos theta for the Pythagoras, for the triangle. You can take any triangle, either on left side or right side. Take any value. What is the value you will get? A divided by root of R square plus A square. That is nothing but A divided by R square plus A square power 1 by 2. Root value. I just mentioned the root value, which is 1 by 2. This is my cos theta. When both the values remain same, magnitude of both the vectors remain same, this E total can be given as E total vector is equivalent to 2 into modulus E, which is E plus Q or E minus Q. You can just take the modulus as both the values remain same. So 2E into cos theta into minus I cap. Don't forget the minus. 1 plus 1 is equivalent to 2, the same manner. 2 into E into cos theta minus I cap. Substitute the cos value. So 2 into, what is E value? 1 by 4 pi epsilon naught Q divided by R square plus A square. E value I substituted. Then cos theta value is Q divided by, A divided by R square plus A square power 1 by 2 into minus I cap. What I have to substitute? Minus I cap. Don't forget the minus I cap. Always be careful whenever you are writing the vector, and here minus I cap should be there for equatorial. All the other vectors you can take. Whenever you are calculating vector, don't forget to put the unit vector. Now, what is the value? What is the value here? 1 by 4 pi epsilon naught 2q, 2 I took inside, 2q divided by, and a also, it is in multiplication, so go for multiplication, 2qa. What is it, the denominator? Here 1 is there, here 1 by 2. So 1 plus 1 by 2, that is nothing but 3 by 2. So what is the value? R square plus A square power 3 by 2 into minus I cap. Actually it is very easy. Comparing to the axial line, equatorial line is very easy. So 1 by 4 pi epsilon naught 2qa into minus I cap divided by R square plus A square power 3 by 2. And again, come to the same assumptions where R is very greater than A. What we have to consider? R value is very greater than A. So neglect the A value, R power 3 by 2. So 4 pi epsilon naught. What is the value of 4 pi epsilon naught 2qa into minus I cap divided by R square power 3 by 2. I neglected the A. And 2 will get cancelled. So what is the value? Minus 1 by 4 pi epsilon naught 2qa I cap divided by R cube is the E vector along the equatorial line. Sure, we are expecting the question from this one, right? First chapter, always remember that one. This question, E along the axial line, E along the equatorial line. One of the question which is very important. And next one is finding the potential value, V value for the dipole as well as for the collection of point charges. Point charge, including the point charge or collection of point charge as well as the dipole. Finding the V value, that is also very important question. So expected the questions of these types only. And last, when you go for the last part, capacitors and Van de Graaff generator. Construction wise, if you go for Van de Graaff generator, so most expected questions are these parts only. Concentrate more on these parts in the first chapter. Sure, you will get a question from this one. Leaving these questions, they cannot cover the first chapter as you are having only 4 chapters for this exams. So don't forget to study these questions. Once again I am repeating, E along the axial line, E along the equatorial line. potential for a point charge or collection of point charges for dipole, potential related to the potential. For sure we can expect the dipole question, potential for a dipole. And last part, if you go for capacitors in series, capacitors in parallel, when the dielectric inserted, what happened to the capacitor, how it is getting affected. There are two cases, so go through the two cases. And at last, don't forget to study the Van de Graaff generator. So these part for sure 5 mark questions will come. Complete that questions by today or tomorrow morning. Within that, later on you can start studying the maths for maths. Because at that time you'll not able to concentrate more on the coming chapters. Second chapter electricity, that is not an issue, you can cover soon. But third chapter and fourth chapter, it will take time. That's what I'm saying. Keep studying. Complete the chapter 1 by today and see you in the next video. Thank you.